Hello and welcome to GM-BIST construction. This is Benedict, your instructor. Today we're also going to learn how to carry out our structural design of a clubhouse. So we will be starting with our general arrangement, modeling, analysis, and our detailing. So this is our AutoCAD file that I'm DWG. So we are going to change this to DXF. So I'll highlight. I just need the floor plan, the ground floor, and the first floor. So I'll just type W, enter, change the insert unit, change it to millimeters. The unit that was actually used for this design, the architectural design, is millimeters. So you change it to millimeters. Then you save it. Let me save it in my desktop as clubhouse. Clubhouse class. So I'll save. Okay, that's now been saved. So the next thing I do is to open my Protastructure. So I will now type my project name, class clubhouse. So I'll choose using British code for this design. Okay. So the next thing I do is to go to my building setup. I click on external reference drawing, click on add, go to my desktop, clubhouse. This is the name of the document. Open, activate it. So in this case, we are not actually importing our grid lines or our columns. We are going to do our grid lines here and our columns here. So let me move the ground floor to be in the middle. Okay. So you can see that the identity of the grid line is actually not showing here. So in this case, I can actually minimize this too, so that when I begin to have, let me close this. So I'll be taking my reference from this. So the first here, what we have here is under the ground floor. So we have this, no number, but this is A, B, C, D, E, F, and G. So let me come back here. Go to modeling, grid line. So this is A. So that will not change the identity of the grid lines. This is B. This is C. Let us check this one now from our architectural design. So we have C here, D, E, F, G. Okay, this one is not it's not number. It's not giving an identity. What we have G here. So this A, B, C, D, E, F, G. This one is supposed to be G and this H. Okay, but we know what to do. So we'll come to here. D, E. This no E. So let's check. E is here. So this is F. Okay, so we'll now change. This is F. You can choose to insert your grid lines to be different, but it's always advisable that you name it in line with what the architect has given you. So this will be F prime. Since we don't we don't have anyone in the architecture, and the next one will be FG. So let's check in the x-axis. 1, 2, 3. Okay, this is 1, 2, 4, 5, 6, 7. No 3. So change in the x-axis. This is 1, 2. This is 4, 4. 5, 6. This is 7. So let's check. Okay. I think there's a mistake on this grid line. Click on it, delete. So you want to target a point so that your grid line will be straight. And these two, we are done with this. So the next thing we are going to do now is to create our columns. So the size of our wall is 225. You can check it. Measure it this way, 225. So this is a column. So we change it to 225 by 225. Change the eccentricity. We have it here. Yeah. 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 For my design, this is how I want it to be. Yeah. Yeah. This way. Yeah. 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 And here. Then we have a window here. Okay. So let us insert our bin. Click on bin 225 by 450. I'll start this way. This way. And this stop here. And this will continue to here. Here to here. Then I join this. Join this. Yeah. Okay, I'll delete this. Take it to here. Okay, done. So I'll go back to my building and set out. I want to bring the first floor. Okay, I shouldn't have removed it, but there's no problem. I can still bring it back. So now I'll move this. There's always a command point for every design. So in this command point here, this is the place for staircase. Okay, let me bring let me bring this back. Let me bring this back to here. So this is where we have this is our staircase. Okay, I also need a grid line here. Let me offset this. I'll offset so that I have my full landing here. And I can also have this beam. Don't worry about that. Let's bring up our first floor so that we can measure it now. So it's better to pick it this side so that I can now place it here. Okay, now the ground floor will give way. The ground floor have given way for the first floor. So this is what we have now. So in this case now, this grid line is not supposed to be here. Grid line is not supposed to be here. Let me offset it to be here. Okay, so I delete this. So this will be C and C prime. C prime. Okay, that's been updated. So we have a cantilever this way, we have another cantilever here, 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 this way, this way, this way. So this is what we are going to do when I extend it. You can say that it's easier this way than for you to do your general arrangement from. Okay, I need to insert this grid line from your AutoCAD. Not properly, please. So this will be A prime. A prime. Update. Let's check. Also have a grid line this side. This will be H. GH, yes. Okay. So you can see that this method is actually very easy compared to you trying to make your walls in AutoCAD and put your columns. You can actually bring the ground floor here, insert your columns, bring another floor. So you can actually model multiple floors in your Protastructure in a blink of an eye. You can just do that. It's very simple using this method I've actually shown you in this video. So I will extend this. I'll click on this beam. We'll extend it. The cantilever beam. Then I will join it from here. I also have a cantilever here. So it's better I don't break this column here. I want it to be a primary beam. So I'll join it this way. So I will extend this too in order to reduce the span. I'll extend this. I will extend this way. So I can also delete this. No, I don't want to split it. So I can extend this. For this, I still don't want to split it. No. Same thing this way. So I can now begin to join. Yes, I'll split there now. This way. Yes. Yes. So we are done with our cantilevers now. So let's begin to check our span. This 4.385. See, okay, 4.385. We are checking in such a way that if we have one that is up to 5 or 6 meters, we increase the beam depth. 4, this 4, this is 5. Okay, resting on this, and there's a wall here. Let's check E this side. Okay, there's a wall here. So for us to reduce, because of the span of this beam now, can actually introduce a column here. Since it's a club and there will be so much vibration, we'll have something of this nature now. So the next thing we'll be doing now, so with that we can still extend this beam now to reduce the span of this slab. So we'll go to our modeling again. We start our slab. So the depth of our slab will be 150, and this is room and post load club. We choose 3 balconies, guest house, stroke clubs. So this one, and so our roof was just 1.2. So now insert this, the slab is actually small. Let's see what Prota will tell us. So we need a beam here for our full landing. This is what we have now. So we now edit our beam wall load. We now load our beam. So we'll go to edit wall load. The unit weight for Nigeria block is 3.47. Now wall height. Now for our wall height, we'll now use our calculator now, so that I can explain something to you. Calculator. Now your wall height, the height of our building is 3,600. Now for you to get your wall height now, it's 3,600 minus the depth of your beam, which is 450. So you have 3,150. So that is how to get your wall height. And so this is in meters. 3.15. So your wall thickness in meters is 0.225. The thickness of the wall that was given to you by the architect. So okay, so you can click on this, copy wall load, highlight it, Ctrl V, you paste. So you have actually loaded your beam. So the next thing we do, for us to run our slab strip, we'll go to modeling, we'll go to analysis. Under analysis, we'll go to building analysis, pre-analysis. So these are our parameters. Under your foundation, we'll be using our allowable stress of soil. We'll be using the zone 1 of 150 kilonewton per meter square, and the soil vertical subgrade coefficient, we'll be choosing our loose sand under lower limit. So this one, lateral drifts, all of them are breast column. A breast column actually means columns are built within walls. Title, you can actually feed this one, made by, checked by, project number, all of that you can feed them. So I will go to edit members. Under concrete columns, select and unselect all. So for our concrete columns, we'll be using Y16 and Y20. Okay, so we don't have any wall here, we don't have any shear wall. So our concrete beam, we select and unselect all. We'll be using 16 and Y20. So for our slab, for our slab, we'll be using Y12. Y12. For our links, that's our stirrups. We'll be using Y10. Okay, foundation level. For our foundation, this will take care of the footings. So for our footing, we'll be using Y16 and Y22, and our links, it's Y10. It will still maintain. Now this soil, now if you click on soil now, see, well, unit weight of soil, all of that, you get the parameters and feed here. So load combination, you must always do this. Okay, it's done. Now I will do a little setting again. But first of all, start with our beam. On that beam, we'll go to detail drawing, steel bar links. I'll check so that I can have my own detail to be showing this way. I will go to slab again, appearance, show number of bars in label. Let me go to foundation again. Under foundation, go to general, minimal pad base depth should be 300. That's what I want. Maximum steel spacing 200. I don't want it to be 250. So I'm okay with that. So let us go to modeling. Let us go to slab strip. Next direction. Now it's going to start at a beam and end at a beam. The condition for slab. So you'll press your control key so that your strip will be straight. So now we have this in spanning all this way. So I will not change for this. I will not change this. So we start this way and end here. I don't have much work detailing because this return has covered all through here. So I'm not change it back to this. Okay, now change to Y direction. This is not straight. So now change it. So this is start and end at beam. So I have another one this side. So I will take it from here, beam to beam. Beam to beam. Make sure your slab strip straight by clicking and holding your control key. So let me change this. Okay, let me see if I can take it. Let's see what Prota will tell us. Okay, the reinforcement have actually fit there. So we are done with our slab strip. The next thing, we insert our stories. So we're designing for 1 story. So this will be 2. Yes. Go back to story 1. Edit story. So we have 3,600. 3,600. Description. Let's say ground floor. Let's say first floor. As on roof, as normal story. The depth of our foundation 1.4. Okay, this is okay. So we still go back. We now generate story 2. We don't need this. don't need this, don't need this, we don't need this, we don't need this, we don't need this. Let us leave our beam. Process completed. Okay, so this is what we have. Okay, so at this stage now I will take away this. I can move it to join here. It's not joined. I don't need this. I don't need this wall. Don't need this wall. Okay, so I can actually create a grid line so that I can partition these walls so that we don't begin to have problem with our roof. So let me offset it. Okay, let me try to identify the length. 5.7. Let me take it this side. 3.7. So it's actually okay. It's actually okay. 3.7 is okay. Let me check this one. 5. 3.6. Okay, no need for partitioning again. So let me do away with this column and have this now. I can either move it or extend it this way to join there. What else do I need to do? I don't need this column. Take away this. I don't need this too. Let's check our architectural design. So up here, this is where the column was, and this other column here. So if you actually leave these columns, they'll be within your bar and dining area. So you have to remove them. And once you remove them, you have to change the orientation of this beam. You can either move this beam, so this is what I mean, move it this way so it will join, or you delete. So let me delete this one. I'll delete this one and extend it here. I'll delete this too, or I'll move this one to join here. So this is what we have. That will have our column supported at this edge. And this edge for our roof. So at this place, let us check our architectural design again. First floor. This is what we have. This stage. There's no window for this one here. This is what we have. This column can still maintain. At 5, there's a wall here. I can maintain this column. At E, it's not supposed to be E, but rather 2. So I can maintain this one too can. Okay, let us delete this. Let's delete this. Take this here. Then have our column at the edge. have a column here. So I think we're okay with this. So we'll now change the wall load for our roof beam. So what I normally do is to take half of this. So let us take half of this. 3,150 divided by 2. 1.5. I just use 1.5. So this 1.5. Okay. So I can copy this. Now you can actually paste this on your external wall for your beams that are going to carry your parapet. The 1.5 is for parapet load, or for safety you can load it all. You paste it all on the beam. For safety you can just do it this way. So we are done with our modeling now. So let me go back to let me check my 3D. So I will tie it vertical so that I can check so that I don't have column sitting on my slab. I think everything is okay. We don't have column at the middle of any building here. So we are good to go now. So the next thing I do now, let me close my 3D. I will now run my analysis. Building analysis. First of all, I will check my building model for errors. Start. We have 0 error. We can proceed to our analysis. So I'll go to building analysis, column and beam, reselect bar, stroke redesign. That is what I want my software to do for me. So whenever you are carrying out your structural analysis and you see something like the difference between decomposed load and slab loadings, there is this yield approach for beam load decomposition, warning difference for building analysis results and decompose. It may be advisable to check the building model. So you go back, increase your members, the size of your members. So I'll say okay. Now for my stiffness in both direction is okay. So I will close this. Now what will actually give me a guide is looking at your displacement. Let me minimize this. Now this is our displacement. I said it's not too okay. You can see this member, it shows that you actually need to increase the member size at this point, even at your roof. So I will close this. I will come back to this member, so up to 5. I will now edit it. 600. Let's to 600. Yes, we're going to run the analysis. Now for this section, I will increase the size of this column. I'll make it 450. I'll actually rotate this. Or let me click this. I'll say 112. Size it that way. So my deflection here is not actually encouraging. Let me check this so that I can increase this to 600. Let me increase this to 600 too. This is 600. This 600. 600. Let's check this. Okay, now I will go to my loading, go to my load decomposition, click this, highlight the two, say okay. Say okay. Close, apply to all be in this model. Okay, let's go back to our analysis. Always check your model. Have 0 error. Do the analysis. Like this. Now you can see that our decomposition, the error that was telling us did not show. Now it's either you increase the member size or you just go to your loading, go to your load decomposition, try to press on the load decomposition so that you have then adequate for your building. So there are actually two ways of doing that. So okay, close. You can actually increase the size of your bars. Let us close this. Let's check post analysis report. Let's check for column. Now then check, we have white 16. Okay. Bin or pass. So we'll now go back to our footing. Level 0. On our footing, we'll now highlight all of them. Right click, insert part footing. Okay. So this is let's make it square. I'll take this to 4. And this will be 1, 2. So that we don't have different type of footings. Try to make them at least similar. So that with this and this, they are the same. So we have 2 columns lapping each other, column footings. So the next thing we say we design it as combined footing. So this is 8. Let me increase this to 4. a designer, so I can actually play around it. This will be 4, 1, 4, 1, 4. I have another combined footing here, so I will delete this. Highlight. Insert combined footing. This is 1, 8 by 1, 5, 1, 6. So these two should be 1, 6, so that we don't have multiple sides of footings. Let's check this. 1, 6, 1, 4. Move this to 1, 6, 2. It all depends on you, the structural engineer. This can be 1, 6 by 1, 6. Let us try. Feed. I want it to be square, so 1, 7 by 1, 7. 1, 4. These two can be 1, 4. 1, 4. 1, 4. Okay. So we are done. So the next thing we do is to